Good morning, pre-calculus students. We're going to go ahead and get started with a problem of the day. So if you want to go ahead and write this down and take a couple minutes and see what you can come up with. Please note you're finding G composed with F. Before we actually do the composition, let's talk about the domains of each of these. Okay, the domain for f of x, since it is a linear function, is going to be all real numbers. And the domain for this radical equation, it's a radical shifted left 2, so its domain is going to be -2 to infinity. Okay. Now, when we talk about the composition G composed with F, we care about the inside function. Okay, so we are putting x minus 4 into our function G. So this domain, I meant to do this. Here we go. This domain right here is going to be important when we think about our final answer. Okay, so when we plug x minus 4 in to our function G, we're going to get the square root of x minus 4 replaces x plus 2. So we get x minus 2. Okay. Now, if we were thinking just about the domain of the radical x minus 2, we know that that's a radical shifted right 2. So its domain would be 2 to infinity. Okay. Now, G composed with F ends up being this right here. So that's most of the points that I'm looking for, let's say in a test situation. Okay. When we look at the domain, that's the other part I'm looking at, we need to compare the outcomes domain and the inside domain to see where they overlap. Since they overlap at 2 to infinity, okay, F's domain is all real numbers, so our overlap is 2 to infinity. So what I'm highlighting here in yellow is your answer. Radical x minus 2 is our composition, and our domain is 2 to infinity. Now, I just mentioned the test. Since we had our no air conditioning day on Monday, okay, and I had already made yesterday's video before I knew about that, our test will be moved to Monday. So we will have, this is going to be our last lesson. and then we will have a couple days of review, and then our test is on Monday. So a couple things in regards to that. Like I said, yesterday's video was made before the cancellation of school. So quiz corrections really are going to be due tomorrow. If you have them for the sub today, please feel free to turn them in. Remember, I need yellow sheet and quiz, yellow sheet on top. Okay, but they are due tomorrow. If I don't have them tomorrow, then you do not get points back. Okay. If you have any questions about your quiz, you can email me or hop onto office hours tonight at 7 and ask me. You can also hop onto office hours tonight at 7 if you have questions about the material. Okay, so what we're going to do is we're going to go ahead and go through our last set of notes for chapter 1. Okay, so this is your last set of notes for chapter 1. Go ahead and get out your 1.9 preview assignment. And what I want you to do is just take a couple moments and turn to a neighbor and talk about what you were able to remember and any of the algebra you were able to do. Okay, so let's go ahead and talk about this. So I'm going to reference your 1.9 preview assignment for, I would say, about half of these notes. So you'll want to write some things down in your notebook also, but some of the things I pull from are from your preview assignment, but I'll do more examples than just that. So this was on your preview assignment, okay, and today's all about inverse functions. We can find inverse functions 3 ways. We can find them numerically, like with a table. We can find them graphically, or we can find them algebraically, like I give you an equation and then we find the inverse. No matter what type of problem I'm asking you to find the inverse for, what is the process? What do we do? We do it by switching x and y. And I know that this is something that you talked about in Algebra 2, and you did some pretty basic examples in Algebra 2. We're going to do some examples that are a little bit more algebra intensive, and we're going to also focus on the domain and range. So since we're switching x and y, this is also going to include our domain and range. So since x and y are switching, x is associated with domain, y is associated with range. Well, then when the x's and y's switch with each other, the domain and ranges are going to switch with each other also. So that's something that we're going to incorporate into our discussion on actually finding our inverses. Okay. Now, before we get into some of the examples that you did, I want to get into just a couple things vocabulary-wise. We have talked about the vertical line test. Well, we have something called the horizontal line test. And it does the same thing, but with a horizontal line. If our horizontal line test, or if our function passes our horizontal line test, then it's going to tell us that an inverse exists. So if our horizontal line goes through a graph more than once, let me give you a nice little visual here. Okay, so if I put this horizontal line through, we hit it more than once. So this pink graph that I drew does not have an inverse. Okay. Now, if a function passes both the vertical line test and the horizontal line test, then we call it 1-to-1, because there would be one input per one output. So this is a graph that passes both the vertical and the horizontal line test. A great example would be our parent function, y equals x cubed. It passes both vertical and horizontal line test, so we call it 1-to-1. Okay. Out of everything we talk about today, this 1-to-1 concept is probably the least of our concerns. Okay. All right, so let's talk about graphically. Okay. Most of our conversations today is going to be finding inverses algebraically, but let's just go ahead and take a look at this example graphically. Okay, remember our process is always to find or to take our x's and y's and switch them. So these coordinates here that I'm highlighting in blue, we would be taking those and switching their x and y for, I'm going to do it in pink, for our inverse. So this coordinate right here, 0, 0, if I switch x and y, well, it's going to stay 0, 0, right? Now this coordinate right here, negative 1, 1, if I switch the x's and y's, it becomes 1, negative 1. And this coordinate right here is negative 2, 4. If I switch the x's and y's, it becomes 4, negative 2. Okay. This coordinate right here is 1, 1. If I switch x's and y's, well, it stays as 1, 1. And then this coordinate right here is 2, 4. If I switch x and y, it becomes 4, 2. Okay. Now, some of you might be wondering, well, Mrs. Homan, you told me that if a graph failed the horizontal line test, it didn't have an inverse. And you would be exactly right. So this graph right here, it fails the horizontal line test because it goes through more than once. So this pink graph, yeah, we found it, but it's not really an inverse because it's not a function. That pink graph is not a function, so we can't really call it an inverse. Okay, so I went through that process to show you how we switch x and y, but this parabola doesn't have an inverse. Now, if we made it half of a parabola, then that would work, but a full parabola does not have an inverse because, as you notice with the pink graph, it's not a function when we actually find the inverse. Okay, now what I want us to focus on is the fact, the algebra of it. Okay, so the very first example I had you try in your preview assignment was this. Okay, now Oops. Let's talk about the domain and range first. So this is a linear equation, okay, with slope of 3. We know that a linear equation that has slope has a domain and a range of all real numbers. Okay, so that's something you probably didn't think about in your preview assignment, and that's fine. Now, we know that f of x means the same thing as y. Okay, so in your preview assignment, okay, if you recall back from Algebra 2 and what we talked about at the beginning of this lesson, we are talking about switching the x and y. So if we switch x and y, we have this right here, and then my expectation is that you go ahead and solve for y. So to solve for y, we would have to add 9 over, and then we would have to divide by 3. So what I would want you to write is 1/3 x plus 3. And then you're actually going to give me some notation. We solved for y, but remember we were finding the inverse. So our inverse notation is this, f inverse of x. So I want you to go ahead and write that f inverse of x is 1/3 x plus 3. Okay. I'm also going to ask you additionally to tell me what the domain and range is. What's nice is we can look up here, whatever our domain and range is for our original, those are just going to switch for our inverse. Now, this example wasn't so bad because both domain and range were the same, but we'll see in the next example how that would maybe be different. Okay. All right, so the next algebraic example you had in your preview assignment was this. Okay, so before we go through the algebra of what you did, let's first talk about what the domain and range would be for this. So if we think about our parent functions and our transformations, right, this would be a square root graph shifted right 3 and up 7. Okay. So its domain is 3 to infinity, and its range is 7 to infinity. Now, I left that graph for us to have a conversation later, and note that I did not sketch that graph very accurately. If I gave you this graph to sketch, you know that I would want more than that 1 point. But since we're just talking about domain and range, I'm not actually asking you to graph it. It's okay to just think about where that shooting star actually lives. Okay. So here we go. We know that f of x means the same thing as y. Okay. So to find our inverse, remember, our strategy, no matter what we're doing, is to switch x and y. Okay, and we want to solve for y. So in order to do that, we would want to add the 7 over, and we need to get rid of that radical. So we would need to take both sides and square them, so that the square root and the square can cancel. So please just leave this as x plus 7, the quantity squared. Then we can add over the 3. All right. Mrs. Homan made a mistake. Who sees it? Okay, I'm going to use my highlighter here. This 7, oh, that's not the highlighter. This 7 right here, how do we get it to the other side? We would subtract it. So this should be minus 7. So I'm going to go ahead and fix that. This is why we do math in pencil, because sometimes we make mistakes, even Miss Homan. Okay? All right. So our inverse is x minus 7, the quantity squared, plus 3. Now I know it's really easy for us to see this and say, hey, we have a quadratic, and I know that all of my polynomials have domains of all real numbers. But that would be incorrect for this example. Okay? Remember that our domain and range for our original was this up here. So when we go to our inverse, our domain is our original's range, and our range is the original's domain. Okay? Now, why is the domain restricted? Okay? Typically, yes, if we have a quadratic, its domain would be all real numbers. But remember, we started with this graph right here. And this graph was a radical, or shooting star, right? Well, something that we talked about in that preview assignment is that our graphs are reflected along that line y equals x. So if I were to go and graph the reflection, I would get this right here. So it's only half of a parabola. If I'm finding the inverse of a square root shooting star, then when we reflect that, we're only getting half of the parabola, which is going to affect the domain. So make sure that you're determining the domain and range for your original function before you do the inverse, so that finding the domain and range for your inverse can be just as simple as switching. Okay. All right, now I gave you a challenge problem. Okay, so let's see how you guys did with your algebra. Now, it was a challenge, so if you didn't get all the way through, that's fine, but let's just see how you did. Okay, now I first want to think about the domain of this guy. We know that we cannot divide by 0, so anything that makes our denominator 0 is not okay. So -1 would cause our denominator to be 0. So we need to exclude -1 from the domain of this function. I'm not going to worry about the range. The range is something we'll talk about in chapter 2 when we actually graph these. Okay, let's just talk about the domain. So here we go. This is y equals x over x plus 1. To find the inverse, remember we need to switch x and y. So our y's become x's, our x's become y's. All right, and the reason this is a little bit tricky is because, first of all, there's a fraction, and that's not a big deal, but I see 2 y values. So let's first make this not a fraction. I am going to take this denominator and I'm going to multiply it to the other side. So we get x times that denominator, and then it's no longer a fraction anymore. Okay, now I have 2 different y values, so it's probably going to be a good idea to try to get those y's together. So let's go ahead and multiply that through. Distribute the x. What I'm going to do is I'm going to take anything with a y and put it on the same side. Okay, so I'm going to take xy, I'm going to subtract over the y, and then this x right here, I'm going to move to the other side. Okay, so now, since both of these have a y in their terms, I'm going to go ahead and I'm going to factor out a y, leaving x minus 1. finally, we're left with just that one y. So we can take what's being multiplied to that y and we can divide it over. So our inverse ends up being negative x over x minus 1. Okay, how did you do? Did you get there? Were you almost there? Even if you didn't know where to begin, it's okay. It was a challenge problem. Okay, but now that we have gone through this one, we'll do another one. Now let's take a moment and talk about the domain and range. So we know that our original had this domain up here, which means our inverse, that's going to become the range. Okay. If we look at the inverse, we see that x minus 1 is in our denominator. So we would need to exclude 1 from the domain because we don't want to divide by 0. Okay. Now, I know that this one was a little different than most of them that you've done. Some of you maybe got halfway through, maybe all the way through. What I want you to do is go ahead and try, with maybe the help of a neighbor, to get through this, finding the inverse with the domain and range. I'll give you a couple minutes, and then we'll talk through it together. Give you about another minute. Okay, let's go ahead and talk about this. I appreciate your patience with me. Might be a little background noise. I have a dog begging me to play fetch with her as I'm trying to go through the notes with you. So it's been an interesting morning, huh? All right. First of all, let's talk about the domain of this function. We do not want to divide by 0, so we would have to exclude -2 from the domain. Okay. Now, we have y equals x minus 3 over x plus 2. Okay. Let's go ahead and switch our x's and our y's. Hopefully you got to hear. I'm hoping that you got our first step of we need to multiply this denominator over. Then we need to take that x through. Now here's where your work could look different than mine. Depending on which side of the equation or the equal sign you put the y's and the non-y's, we could look different. So I am going to put the y's on the left side. If you put it on the right side, I'll talk about how yours might look a little different, okay? So I'm going to keep xy here and subtract y over, which means I would be subtracting 2x over to be with the -3. Okay. Then I'm going to take this right here, and I'm going to factor out the y so that x minus 1 is left. Then we can divide the x minus 1 over. Okay. So here's the deal. My inverse ended up being -2x minus 3 divided by x minus 1. But if you put your y's on the right side, unlike me, then you would have gotten 2x plus 3 over 1 minus x, and that is the same thing, okay? Those are equal, okay? They look different, but they're the same because of where the negatives are, okay? So either one of these are okay. In addition to this, though, you need to tell me the domain and range, okay? Now, we know that the range comes from the domain of our original, so this right here becomes the range for our inverse. And then, if we look at our inverse, we can see that the value x equals 1 would cause our denominator to be 0, so that is what we need to exclude. Okay, one more bonus example because I want to make sure that we all really understand how to do a problem like this. A problem like this is very important. Hint, hint, wink, wink. Okay, so here we go. This guy has a domain and a range of, write it down. Domain, -2 to infinity, range 0 to infinity, because we have a square root graph shifted to the left. Okay, maybe you're working ahead of me, and I think that that is awesome. Here is our function. Let's go ahead and switch x and y. Okay. Nothing over here to add or subtract over. But since there is a radical, we can square both sides so that we're left with x squared equals y plus 2. And then we could subtract that 2 over. So our inverse is x squared minus 2. But our domain and range come from the flip of our original. So our domain is 0 to infinity. And our range is -2 to infinity. Okay, so here's what you need to do for me. Tonight you have a homework assignment that's in the book. Do your best. Pop onto office hours if you have questions. Check your answers and work in Calc Chat for odd answers. Okay? Tomorrow, your quiz corrections are due. Unless you have them today, feel free to turn them in. I will probably give you feedback electronically, so check your email for feedback. That's probably the faster way for me to get you the feedback right now. Okay?